This week, Dr. David Brumley from For All Secure is with us to discuss bringing autonomy to AppSec. Then, in the enterprise security news, ZeroFox has a $1.4 billion blank check. Corellium raises $25 million in a Series A. Gray Noise makes its data free to help out Log4j sufferers. AWS suffers its third outage in a month, coincidentally hindering Gray Noise's efforts to help Log4j sufferers. Ditching unicorns for dragons, yet another easy way to become domain admin, thanks Microsoft. New report finds that current phishing training isn't effective and is even potentially harmful. Finally, we'll take a look at some of the biggest stories and interviews we discussed this year in ESW, and we'll wrap with our thoughts and hopes for 2022. The last episode of Enterprise Security Weekly for 2021 starts now.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where we talk security vendors and aren't afraid to name names. It's Enterprise Security Weekly.
Let's face it, cyber attackers have the advantage. ExtraHop is on a mission to help you take it back. Regain the upper hand with security that can't be undermined, outsmarted, or compromised. When you don't have to choose between protecting your business and moving it forward, that's security uncompromised. See how it works in the full product demo, free online at securityweekly.com/ExtraHop. Welcome to Enterprise Security Weekly and happy Pfeffernuss Day. I think I said that right. This is episode 255, recorded on Thursday, December 23rd, 2021. I'm your host, Adrian Sanabria, and joining me today is Mr. Tyler Shields. Hello, Tyler.
Hey, Adrian. Decided to do this final one from home, so not in the studio office today. And yeah, how are you?
I'm good, and it seems appropriate. You know, we're just a few days away from time off and holidays. I think for several people on this call, this is really the last thing we have going on that's work related before we all take some time off. Do you know what a Pfeffernuss is?
I definitely wrapping up on this call. I have two little meetings right after this, and I am done for the long weekend. And I have no clue what a Pfeffernuss is. Let me see if I can fathom a guess. It sounds like it could be a type of sausage that you drink lots of beer with in Germany.
It's holiday related. I'll tell you that.
I was close.
It is a German spice cookie. And it looks.
Oh wow! The fact that I even had it in the correct category, being food, surprises me.
Yeah. Fluffy cookies made with ground nuts and spices covered in powdered sugar. They look kind of like almost like a compressed sweetbread. You know, look like a very kind of fluffy type of cookie, not like a hard cookie.
Well, I think that we should have some audience members who know how to make these. Send them into G-Unit Studios. Bombard Paul and team with them, because they love it when they get random things in the mail and have no idea where they're from.
They do.
Johnny.
They do.
Yeah,
indeed.
They do love that. And I've heard stories of some of the things that they've had delivered that were just like off the wall, bizarre stuff. So definitely please send some Farfignugans or whatever they're called into G-Unit Studios. Attention, Paul Asadorian.
They've got to smell better than meat scented candles, though.
And definitely would taste better, too, I would have to say.
It would definitely taste better, yeah. All right, an announcement. Security Weekly listeners save $100 on your... Oh, are we still doing this?
Nope, stop, cancel it.
Late breaking news. If you haven't heard, RSA got moved to the first week of June. And I think we swapped out that announcement and I missed it in my show notes. The actual announcement.
That whole movement to June is going to be a super interesting thing, because RSA is now going to be over the top of the Gartner Security and Risk Show same week, and it's going to be in the same month as Reinforce.
Yeah, and we actually CRA acquired an events company that has one that same month also, but it's a couple weeks away. It's towards the end of June. So yeah, that's interesting. I did some analysis a couple years back on events in cybersecurity. We have well over 2,000 events a year, or at least we did back in like 2019, I think it was, when I did that research. And the heaviest month was June. In fact, the single day with the most simultaneous cybersecurity conferences, I think, was June 1st, with 19 conferences going on in the same day. So
19 conferences. That's absolutely insane.
I think Gartner's and some other folks are probably going to end up moving their stuff.
Yeah, we'll see. We'll see.
All right. So the announcement I should have read is to let you know that if you have a specific guest or topic that you would like us to have on the show, you can submit those suggestions at securityweekly.com/guests. You can complete that form there, and we go over those on a pretty regular basis. It's actually a very fun process to go through that list. All right. And today's topic for our first interview, actually our only interview today, is bringing autonomy to AppSec. We're very excited to have Dr. David Brumley, CEO and co-founder of For All Secure, with us today. He's a professor at Carnegie Mellon and the previous director of Scilab, part of Carnegie's Security and Privacy Institute. He's contributed a lot of stuff to the industry. He's been involved with it for a while. But I think my favorite thing from his bio is that he's the faculty mentor for the CMU hacking team Parliament of Pwning, or PPP, which is internationally ranked as one of the top CTF teams in the world. Welcome, David.
Hey, well, thanks. Glad to be here.
Glad to have you. Lots of David was just regaling us with just super interesting stuff that I guess going through academia, writing all these papers. Are you comfortable sharing that story with us that you just told about when you got to meet Obama?
Oh, yeah. So we were talking about, I had learned that in international protocol, actually being a professor ranked higher than a doctor. And Adrian asked me, how do you know that? And I was like, oh, I was at the White House and the protocol officer told me that. And the reason I was there is it was sometime in 2013, I think. It's hard to remember. But I had won what was called the United States Presidential Early Career Award. So it was the highest honor that the U.S. gives to young scientists. And I got it from Obama. So it was kind of cool to go to the White House and meet the president. And it was just an all-out amazing trip.
Yeah, it's great. Yeah, and time-wise, yeah, there's only, before the pandemic, during the pandemic, and after the pandemic at this point, everything else blurs.
It really does. I mean, so what I was working on then is actually the same thing I'm working on now, just in a different context. So for a long time, I've been looking at how do we automatically find exploitable bugs before attackers? And back then it was really a research question. And today at For All Secure, what we're trying to do is we're trying to commercialize that research.
Hey, real quick, I have a quick question for you. Did I hear that you ran a team, or were on a team, or was part of a CTF team? Can you give me a little more color on that comment that Adrian threw at me that I didn't even see coming?
Oh, yeah. So still at CMU, we do a couple things for the community. And it's kind of interesting because since I've moved into business, it's actually just a different mindset. But when I was at CMU, I had an amazing student named Brian, and he wanted to play in the DEF CON CTF. And he started, he told me one day he was trying out for all these other teams. And I said, hey, why don't we start one at CMU? And so I worked with him and a couple other people at CMU, and we created Plaid Parliament of Pwning. And this was, around 2013 as well. And since then, we've gone on and we've been, ranked number one in the world many times. And I think we have 5 DEF CON wins. So 5 black badges, considered a pretty big thing. And then one of the things we also do is we run picoctf.com, which is a high school hacking contest, which is used, I think last time I checked, we had like 100,000 registered users. And so I'm a big believer actually in CTFs as a great way to learn computer security skills.
Yeah, it's that is an absolutely amazing story. It's a little known fact because I don't generally tell people, but I have 2 black badges from CTF at DEF CON myself in 97 and 98. So way back in the day, but it caught my ear that you were a fellow CTF person. So that's awesome.
Yeah, I mean, haven't times changed, right? So when you look at CTFs, for those of you who haven't played it at a place like DEF CON, they're full spectrum attack defense. Everyone is given compiled binaries, so you have no source code or anything, and your goal is to be able to exploit other people and defend yourself. And so that's kind of what I grew up with, thinking of as computer security, and boy, has the field expanded since then.
Yeah, back when I won it, it was a little bit different. You were given nothing. You plugged into a network and you tried to hack every other player, winner take all. So it was quite a bit more deadly and cutthroat back then. But because if you got in and got the opponents, if you popped the opponent, the first thing you did was gank all his wares because he might have some 0-day that nobody knows about. So it's just it was a different game back then. But that's super cool, man. I love that. Back to you, Adrian. I know you actually have an interview to conduct.
Yeah, no problem. No, it's very interesting stuff because a lot of the people interested in security and getting into security, when I started out, I don't think I found out about CTFs until DerbyCon became a thing. I think that's the first place I really encountered them and learned about them and actually participated in one. But pretty important, for getting people interested and getting people into the industry. In fact, Pico CTF, there's a local high school cybersecurity class that I talk to on a pretty regular basis, and they've used Pico's CTF before.
Oh, it's fabulous. It's definitely been a labor of love, but we're excited that people have found it valuable and we continue to run it.
Absolutely.
It's actually been good for CMU as well. So I don't know if you know this, but if you play in Pico CTF and you're one of the top 10 teams, I'll personally write you a letter of recommendation to any college, not just CMU, but anywhere. So sometimes that gives you a little extra something on your college application.
And that is a pretty cool perk of doing well in a CTF.
Yeah. It's free, but I think it's meaningful.
So before we dive into some of your research and your company, would you provide us a little bit of background on how you found yourself getting into security? Yeah, it looks like you have a background maybe in more generally computer science and maybe also electrical engineering. Is that correct?
I have both. So really, the story starts right after I got out of college. I went to Stanford and I became the computer security officer. So this was before CISO actually being an elevated title. This was more like an IT job. And just to date it, this was like 1998. So this is when it was literally google.stanford.edu. I remember Google would go and, go index web pages and bring down entire networks because we had much more bandwidth than other people. And I got really interested in computer security because I kept seeing people hack the entire Stanford network, right? You find a new vulnerability. Back in the day, it was in RPC, for those of you who remember that. And you just own all the different machines. And so I was doing IT for many years, and I decided, hey, I want to go deeper into this. And so I went and got a master's at Stanford in computer science, and I got my PhD at Carnegie Mellon. And now I'm a tenured professor of CS and ECE at Carnegie Mellon.
Yeah, that's a heck of a perspective to bring to really any company or role, at this point. Yeah. So, in kind of moving forward, obviously you did a lot of stuff between then and when you started this company, but it sounded like did this company start with the DARPA Cyber Grand Challenge, or was that just kind of like a footstep in the path of founding For All Secure?
It was actually a footstep in a path. It's kind of a funny story and harkens back a little bit to CTFs. So back, it was probably 2009, 2010, we were publishing papers in something called automated exploit generation. And the whole idea was to show that we could create, application security techniques that could create working exploits, novel exploits for compiled programs. And so this was our research. And it was pretty funny because at the time, and I won't say who it was, But all these people in industry were laughing at us. There was this huge mailing list where someone was making fun of us, quite well known in security, for about 6 months. So we had been working in automated exploit generation and back then, and we just continued to mature the research. And it got to the point that enough of the community was working on this that DARPA said, hey, maybe there's something to this. Maybe we should see if we can do what we did with autonomous cars for computer security, because we all know that the workforce just is not scaling today. And it's funny, you're talking about CTFs, right? Like throughout this, even when people were making fun of us, we were, winning black badges at DEF CON. So we actually know how real exploits work. But our entire goal was to take kind of what those high-end hackers did and build automated algorithms to do it. And in some ways also to take advantage of the law of large numbers. Like maybe if you're given one program and the goal is to find an exploit, it really takes a human. But if you're given 100 programs, I'm sure you can find an exploit in 15 of them, a brand new 0-day. And so we started doing research in that, and then we entered the Cyber Grand Challenge to show full autonomy is possible, and we won it. And it's really cool. It's kind of like the art of the possible, but that doesn't mean it's the art of industry at that point. And so we won that, and we had created For All Secure right to compete in that. And the reason that we created For All Secure is just to have focus. As an academic, you're publishing papers, and we wanted to not focus on that. We just wanted to win. And so I recruited my grad students, some CTF players, and we built Mayhem. And then in 2016, after we won, we went around for a couple of years, just continuing to improve it. And then we decided, hey, this is something really the world needs. And so we commercialized For All Secure. And so it's a little bit of, if you kind of think about a parallel, it's a little bit like autonomous driving, right? Where it begins in a lab and then it becomes, hey, you can show you can do this in a course, like with the DARPA challenge. And then today we have Tesla. And so we think there's going to be the same sort of course in computer security, right? The workforce challenge isn't going to go away. We need to let humans focus on what they do best, the creative stuff. And we need to teach computers how to hack.
So first off, you're a better man than me. I'd totally be dropping those names of those people that made fun of you back then. But also, so this Cyber Grand Challenge, from the sound of it, were the rules for it to be entirely automated?
It was completely automated. So the guy who ran it was a DARPA PM who had actually won a black badge, Mike Walker, actually. So he played on... I think he played on the team Hates Irony, which was an anagram for Raytheon SI at the time, for those of you who kind of know CTFs.
That's funny.
So Hates Irony, Raytheon SI. So yeah, the entire idea was like in a CTF, a full spectrum DEF CON CTF, you all have services, you don't have access to the developer, you want to hack other people, and you want to defend yourself. And so the entire idea was to replicate that, but with a machine. So machines are attacking others and machines are defending. And these are all with applications that no one's ever seen before with zero human intervention. And so it's quite different than I think maybe some listeners may think. This wasn't like there were known vulnerabilities or something. It wasn't like you got log4j or something and then you had to exploit it and land and pivot. This was all go find 0 days.
Yeah. Fuzz from scratch, right?
That's what it was about. And then for defending yourself, you had to patch the vulnerability, but actually gameplay worked into this, much like in industry. So if you patched it, you had to make sure you didn't lose functionality. And you also had to make sure that you didn't have too much overhead. And this is where the gameplay was pretty interesting. What Mayhem would actually do is it would create like 16 different candidate patches. And then it would try to figure out which was optimal to play at that point in time. And so actually, like one of the reasons we won is other people would field patches that would be extremely slow and have huge performance degradation. So they focus too much on the computer security point of view and not enough on the end-to-end business case.
Wow. So you're not only automating finding the exploits, fuzzing from scratch on something you haven't seen before, but you're auto-generating patches for the exploits that you find, not just a single patch, but a whole batch of patches that you then do fully automated performance testing on and choosing which one is optimal. performance-wise.
Which one, and even when to do it. Like if you have a patch that has 40% overhead, you probably don't want to field it until you think that you're actually being exploited. It's a little bit like you don't want the overhead unless you know that it's really needed. So there was a huge gameplay part of this. Actually, we spent a lot of time thinking of cyber war. And if you played CTFs, there's things like you always focus on the weak first. So if you come up with an exploit, you always want to try it against the lowest scoring candidate first. Because, if something goes wrong, you don't want to be giving a strong player any extra hints. Things like that. There's a whole bunch into this contest.
This is absolutely intriguing to me. I find it so, coming from a pen testing background, having written fuzzers, having actually helped write a static analysis tool for a vendor from scratch, this is absolutely super cool to me. The question I have is you do all of this outside of the source code. So you're actually automating full reverse engineering to some kind of IR language, or are you not using SAST and instead doing fuzzing and looking at responses?
The DARPA did this right? They didn't say how you should do it. They said, all we care about is the result. And so we used almost zero SAST.
Okay.
Which was kind of funny, right? Because most people in industry think of SAST. Okay, what I'm going to do is I'm going to run it. I'm going to get a list of all the vulnerabilities. And if I can just go through that checklist, just like, we can all go through our holiday to-do list, we'll be done. We use basically zero SAST. So we would take the binaries, we would raise it up to an IR, but we use the IR to do things like fuzzing and symbolic execution. So symbolic execution is where you model paths in the program as formulas and logic, and then you use the math to try to drive execution down them. And that's really the genesis of For All Secure, because we're saying something a little bit different than industry. We're saying that it's always better to say, hey, here's a known vulnerability, and I'll give you a proof of concept exploit, rather than trying to enumerate every possible vulnerability. And that's just because there's this, fundamental trade-off. If you're going to try to list every possible problem, you're going to have false positives. Well, if we can give you a working exploit, you know exactly what to look at.
And then the patching layer, how would that work over the top of it? Are you doing like a binary wrapper? Are you modifying the binary directly to change the pathing? Like, how does that actually operate?
We modified the binary itself. So we would raise it up, and then we had to do binary editing. So, if you had a patch and it wouldn't fit, if you guys are big into binaries, right, often they're not relocatable. So you'd have to figure out, hey, can I put in the segment of code to check if I'm getting exploited? What if there's not enough memory there? And then I'll jump out to some other area of a code where I have enough, then I'll jump back. Well, that, by the way, that jump out and jump back, that introduces overhead. So maybe that patch is less efficient than one that you can inline completely. So it's these sorts of things that the machine was doing completely automatically.
Absolutely amazing. Adrian, we'll go back to you because I have a gut feeling I could geek out all the way down to the bits and bytes here forever.
Yeah, definitely. Yeah, there's a lot to get to, like, and to remark on here. So, kind of fast forwarding, from that Cyber Grand Challenge, we've seen some companies, some more successful than others, that have done really well in these kinds of competitions and have these strong academic backgrounds. But I suspect there's kind of an interesting journey to take to get from that to a product that you can sell and that you can market. So it'd be interesting to hear some of that. I love that the product is called Mayhem, by the way. Reminds me of the I'm trying to remember what insurance company that had the Mayhem campaign. Allstate.
Allstate, yeah.
Yeah, it's the reason we couldn't get the domain name, right?
Oh, really? Okay.
Yeah, because Allstate had registered it because it was part of their marketing several years ago. So we called it Mayhem, right? The idea is the computer uncovers the mayhem before a real life attacker does. That way you can be prepared and handle it on your own schedule. But creating a company has been really interesting. We're probably on our fourth version of it, right? So version 1, when we were starting to look at this, we were academics. We wanted to show what was novel in advancing the state of the art. And we're really good at pushing symbols. So when I go in and say SAST is the wrong thing to do here, it's not because I don't understand SAST and haven't even published papers in SAST. That's because I think it's the wrong thing to do just from a security standpoint. So that was the first. The second is when we went and we did the Cyber Grand Challenge. So we're no longer worried about advancing the state of the art. here, engineering starts to play a bigger role. You want it to be efficient. You want it to be reliable, but it still only has to work in one context. When we created the company, probably the biggest shift is going from research tech to an actual product. And I think it's kind of interesting because it parallels in some ways open source versus commercial products. Like when you're doing something like Cyber Grand Challenge or research or even open source, it has to work for just you. But when you start selling something, it has to work for all your customers and all their requirements. And sometimes the sort of things they put up as barriers are not ones that you would even think of. But you have to handle. And you start having to handle things like, how do I install it? Making sure you have enough disk space. Handling, people always want to say, hey, how do I integrate this with my own accounts and my SSO that I already use? Stuff like this. And so those have been kind of the interesting parts.
What are some of those unexpected barriers that you ran into? Just wondering if you have any interesting examples there.
So I think there's been a couple. So one, the biggest has traditionally been that Gartner did not recognize what we did. And, Gartner is a little bit like Big Blue. There's a large set of people who kind of look at them for guidance. And we're like, look, Cyber Grand Challenge, DARPA spent $60 million and no one used SAST. This should be an indication if you want to automate, that's probably not the best approach.
Yeah.
And so I think that was the first one is kind of in marketing. The second is what you're doing or what Mayhem's doing is it's taking your app and then it's trying to hack it. So you have to give the app to Mayhem so that it can run it and reset it. And we ask people, hey, you got to give it to us as a Docker. And this has probably been the biggest barrier that we didn't even think about. We thought, oh, people Dockerizing their apps. Everyone can do this. Docker super, especially today, Docker super popular. And it turns out you can go into pretty much any high-tech company, and while they may be Dockerizing a lot of their code, certainly it's not ubiquitous. So even problems about just like, how do you get the code into Mayhem has been interesting. I guess the other piece is we focused really on executable code. And so we've had to start adding in more interpreted languages. And we focused on executable code just from like DEF CON, right? Like you never got, like I always laugh when people are like, RE.NET code. I'm like, dude, you can decompile .NET. It's not hard. There's no reverse engineering. So that was part of it, is just handling all the different languages out there.
Yeah, and I think Tyler and I can definitely relate with the Gartner issue. We were both industry analysts, neither of us at Gartner. So that was something that, as a non-Gartner industry analyst, you heard constantly. What was more often, it was Gartner stuck us in the wrong bucket. They misunderstand what we do. And yeah, somewhat, they don't have a category for us. So we're having a really hard time educating the industry as to what we do and why it has value. Yeah.
And they also, like an academic, there's either static analysis or there's dynamic analysis. It's either one or the other. But actually, dynamic application security testing means something very specific in Gartner. It's basically just a web scanner.
Yeah.
And so even something that's kind of universally with everyone else in common sense definition, given dynamic analysis, you're in the wrong Gartner bucket if you say that.
Yeah, and so that's a good clarification. I think when you say application security in general, most people, or at least to a lot of people, that's synonymous with web applications. And it looks like you do API security as well. So I think it would be good to focus on that a little bit, on specifically, what your tools can work with. What kind of software?
We've increased it over time. So when we first commercialized, our core product was on any executable code. So this would be compiled C, C++, Fortran, Go, Rust. And the reason that we focused on that is, quite honestly, that's most of what we were hacking before, cyber physical systems. And so Mayhem for code for binary, we've literally been used to check weapon systems. We've been used to check ICBMs. And then we've also been used by companies like Cloudflare and car companies. But when you start looking at kind of the broader market, there's a huge number of people who are just putting a web app, right? They're not really developing something that's going to ship on 1 billion devices or is safety critical. And we looked at these and we said, a lot of these are just getting connected through APIs. And so we created Mayhem for API specifically to try to focus on that one part of the problem and do a really good job on it. So we have two things we handle: Mayhem for code. So if you can put it in a Docker image and it's executable code, we can analyze it. And then APIs, where it can be any code as long as you're exporting something where we can represent it in an open API spec.
So it can be like a REST web-based API in that case.
It can be. So it's REST in any language. We try to stay a little bit about saying we're not web overall. And this is kind of one of those questions. The academic in me is the one who doesn't want to say it. The marketer in me maybe does. When you start talking about web, really like your web browser is doing all this JavaScript rendering. So even figuring out what routes are there can be complicated. And it's kind of easy to do a crappy job. And we didn't want that to be the ethos of our company. So when we say API, we're specifically saying you've told us the API routes, the things that you care about that are going to be getting potentially untrusted information.
So you're talking about DARPA not caring how you do it. They're only interested in the outcome. And it seems like that had a big impact on how your product works, how it delivers that outcome for customers. And it seems markedly different from what we currently see in the market, where a lot of SAST and DAS tools just kind of blast away with this huge laundry list of different styles of tests. And this huge stage of analysis is just trying to separate out the false positives from the true positives. So, touch on that a little bit on why you chose that route. And also, I'm kind of curious how you handle that conversation with customers, because I feel like the typical cyber analyst has a little bit of this FOMO mentality where, like, a bajillion false positives they seem to be fine with, but the idea that there might be any false negatives, they're somehow not okay with. I don't know if you've had the same experiences.
I have. That's part of what we're trying to change. I don't know how successful we'll be. So when I was at Stanford, right, I mentioned this at the beginning. Coverity was just spun out. I actually took classes from Dawson Ingler, and I know some of the co-founders of Coverity fairly well. And what I saw with tools like that is they have, 25% or higher false positive rate. Of course, you can always come up with a data set, like an industry data set, and then kind of play to that data set to show lower. But you can have quite a bit. And there's this really weird, it's almost bad for industry. The way you sell those tools is you go in and you have to find a bug. Literally, someone could give you formally verified code, and the only way you're going to sell is if you find a vulnerability. And so I thought the market forces were a little bit on. Compare that to a CTF, or compare that to actually real life and you're an attacker. All you care about is, do you break in, right? And so that's really what Mayhem focused on. And we talked a little bit about CTFs and Pico CTF and things like this. The way we went about this is I'll tell a little story. So one of the people that we recruited from Pico CTF, his name is Richard Zhu. Most people know him today as Fluorescence, as part of Fluoracetate, the guys who owned the Tesla 2 years ago. So he makes, hundreds of thousands of dollars a year on Pwn to Own. What we were trying to do is replicate what they do with Mayhem. And look, if you go hire someone of that caliber, he's never going to tell you, I found all the bugs. He's never going to also give you a false positive. What he's going to give you is a proof of concept. And what we tell people is we think that that's the right way to go. It's much easier, even if you're a leader, to have a proof of concept, because while, kind of hypothetically, their mindset is, I want to estimate the risk. If only I knew every problem, I could estimate risk. Instead, what we're giving you is actionability. Here is what we actually know we can exploit. And so I kind of go into the conversation. Do you really want a big list of, if you're driving down the street, of all the bad things that can happen, you're going to end up in a tank or never leaving your house? Or do you really want to know, here's something that I can prove?
Yeah, and I think all the CVEs we see every year, that's one of the things we've learned from the vulnerability management industry from companies like Kenna Security, that it's just a tiny, tiny, tiny fraction of those vulnerabilities that can actually cause harm, actually represent any risk to your company. A lot of them just aren't exploitable. It used to be really irritating seeing all these come out where they'd say, this RDP bug might be RCE, and years later, you find it never was. And it's certainly from a defender perspective, it's very frustrating to see so much of that, because it just wastes so much of our time.
Yeah. The other thing that is kind of interesting, so when we did the Cyber Grand Challenge, so we would find an exploitable bug, and we talked about we'd patch it, and then we try to decide whether we should field that patch. And so we weren't given like a test suite. How did we decide whether or not we were going to have a regression problem? What Mayhem is trying to do is it's trying to find untested code and test it. In some sense, all an exploit is an input that triggers untested code, right? At that point, that's really all it is. And so what Mayhem is trying to do is really kind of at a basic theoretic level is trying to come up with an input that tests 100% of your code. And so when we came up with an exploit and we patched it, we would use this test suite created by Mayhem of both good and bad to determine whether there's any regression. And so this is why I say, like, if you really want full autonomy, you actually don't want to just find where the problems are. You're also going to have to solve this regression problem, because at least what I see in industry a lot is the barrier to becoming more secure isn't finding the vulnerability. It's deciding whether you can field the fix.
An excellent point, I think, to end on. I love the philosophy of it there. I think that's something we need to adopt more broadly into other parts of security. And love the functionality of the product as well. I've got one final question for you. Why is the A upside down in your logo?
Oh man, that's a geekgasm. So when we found the company, none of us are what you would call graphic artists. Probably my 8-year-old has better drawings than I do. And so we needed a company logo, and the upside down A is the mathematical symbol for all. So in formal logic, you have for all, or there exists, and then you do proofs. And so really behind Mayhem, when we were writing these papers, we were using this math to show, how our system worked and prove properties about it. And then it became our logo. And kind of funny, our default logo was just it's called LaTeX. It's the scientific editing system for all symbols. So it was literally / for all, if you know LaTeX.
I love it. Love a geeky backstory. All right. Yeah. Thank you, David, so much for joining us on Enterprise Security Weekly today.
Thank you, and have a happy holiday.
Same to you. Stay tuned. When we come back, we're going to go over the enterprise security news.